Introducing networked vehicles, a system that integrates the Microsoft Gadgeteer hardware with a web-based interface to provide a complete intelligent vehicle system. The system is designed so that the user interface can be run on any device. Here we have a tablet, a laptop and a phone all interacting with the same hardware at once. The intention being that one vehicle can have any amount of interfaces to the intelligent system. A handheld HD projector is also accessing the system. We intend to extend this technology into a holographic touchscreen. The system backend is running a private web server, which the user interface connects to. This backend uses a highly optimized version of Debian Linux. We have created C and C# programs to interface with the Gadgeteer hardware. This provides us with 3G, SMS, camera and GPS technology. Through the user interface, we can instruct the Gadgeteer hardware to turn the camera on and off. Real-world applications of this include parking cameras, security, and much more. The system can send and receive text messages. Here we are activating the C# Gadgeteer interface and are sending a text to the SIM that is housed in the Gadgeteer hardware. Messages then automatically appear in the user interface. The system can be programmed to respond to messages automatically or carry out any given custom procedure. When the Gadgeteer receives a message, it outputs the message in XML format, which is then easily readable by the web application user interface. The user interface also includes a basic contact management system. Contacts can be added or removed through the interface. Any message that is received from a contact will be recognized by the system and their name pinned to the message. The system also supports the sending of messages through the user interface. Again, we made use of the XML file format to send messages to the hardware. Real-world application could also include automatic messaging, or even the sending and receiving of data if 3G were not available. Here we can see the GPS feature in action. If I activate the GPS through the user interface, the Google Maps API will be turned on in the bottom right corner. The location will be continually updated with the location we're sent from the Gadgeteer, which is saved in an XML file. Here we can see that in action as the Google Maps API is updated continually.
Before we achieve the task of configuring the launch and shutdown scripts for the target operating system, we have to skip the login page which all the Linux-based systems have. To achieve that, we go to the daemon configuration file through root terminal using the nano editor. There are a few lines of script in this file and we just added 2 lines to remove the login. We then save it and close it. Now when we reboot Debian, it will auto log in to desktop without asking for the username and password.
We made a table with the package name and the section where it belongs and if we wanted to remove it or not, and the reason why. For example, in the section cross-platform, we wanted to remove CDRDAO package because we did not want to be able to record any audio on our operating system. And after we remove our packages, we need to put app.get update, so that when we next time try to list it, we would get the final list of packages. To be able to delete all the packages in one go, we created a bash file, and that would run the script and delete every package included in this script. To delete the package, we need to put apt-get purge remove and then the package name. And we make this command for every package we want to remove. To be able to install the packages into your system, you should put into your terminal apt-get install, for example, Apache 2, and then press the enter button. And it will give you the number of packages to be installed with all the configuration scripts and dependencies, and you should press the yes button. We also tried to find a solution how to make our operating system unrecognizable. So we put apt-get purge remove desktop base, and this removed all our Debian branding. The main purpose of removing all the unused packages is to save space and to reduce software footprint. Initially, our operating system was taking a space of 3.3 gigabytes that could be checked by putting the command df-h.
Hello everyone. In this part, I'm going to outline how the connection between the Gadgeteer device and the page server is made. So this is Debian 6 for our project Network Vehicles. The C application is written using the libusb open source library. Here's the command we use to compile the code. You can see we have to include the LUSB 1.0 flag. Let's go to the main. Okay, so in here, first we have to initialize the libusb library. This is an open source library written entirely in C. That's why we've chosen this programming language. It also supports over 15 more other languages. So null over here means the context. We have only one. We don't need to declare it. Now let's run the connect function. First let's have a look at this read from file. It just reads from a file in the same directory. Now let's see, in the connect, it creates a handle on the USB device using the device vendor ID and product ID, which are unique, and we found this using other programs written in LUSB by looking at the descriptor, the endpoints, and things like that. Over here, I would like to point something really important. If the device is freshly connected and Gadgeteer hasn't run before, then the driver from the kernel is attached. So in order to have the interface and to communicate with the device, we need to check that, and if the kernel driver is attached, we need to detach it. Okay, and now we claim the interface. Good. Now after we have the interface, it's time to receive data. The Gadgeteer will constantly send status messages, like for the internet, camera and GPS. and also when an event occurs like SMS or TCP data received. Now what it does next, it reads the request.xml file, and this process is done every single second. Now let's have a look. We're in the same directory as the page server files. Now let's try the gadget here. Okay, we can see over here, trying to detach kernel driver. Kernel driver is successfully detached. This is the first time we run the gadget here after it was connected. Now if I do it again, you see we have directly the interface. No need to claim it. Okay, if I send camera on, see, it sends it. It says it sends the data between the data tags in the XML file. Okay, now if I just make it camera off. Okay, we receive messages from the gadget here with status. You see, camera is false now again. Okay, let's try for GPS. You see the Google Maps API has started. Now transfer successful, 66 bits of data sent. Okay, camera false, GPS true, turn GPS off. Okay, send, transfer successful, GPS false. Okay, so that's it. Thank you for watching.
Section of the video, we are going to be discussing the key elements of the main report. Firstly, we had to decide which operating system we were going to use, whether it be Windows, Mac, or Linux. We decided to go for Linux because it is a customizable operating system. Having decided to use Linux as our operating system, we then needed to decide which Linux distribution we were going to use, whether it be Debian, Ubuntu, or Linux Mint. We'd chosen Debian because it was very robust, the source code is readily available, and it allows you to be in control of the system. We then needed to choose our hardware, whether it be the Raspberry Pi, the Gadgeteer, the Kinect, the iPad, or the Arduino. We had firstly decided to go for using the Gadgeteer because it enables us to use the camera features and the GPS features, which we would need in our network vehicles project. Also, we had written a lot of our code in C#, and Gadgeteer is great with C# as it has very good Visual Studio's integration. Next, we wanted our application to run on a multiple amount of devices such as touchscreens. Therefore, we had chosen the iPad to do so. Next, we decided we needed to choose our web clients, such as Midori, Chromium, or Dilo. We'd chosen Chromium because it is open source and it has a kiosk mode which enables us to run the application in full screen. Next, we needed to decide our web servers, whether we would use IIS, Apache, Lightspeed, or Tiny HTTPD. We decided to go for Apache because it is free, runs on multiple operating systems such as Linux, Windows, and Mac OS. Next, we needed to decide which scripting languages we were going to use, whether it be PHP 5, JavaScript, or Python. We decided to go for PHP 5 because it is open source and is a cost-effective way of hosting. We then need to decide our graphical user interface, whether it be JavaFX, HTML5, or Adobe Flash. We've chosen HTML5 because it is cross-platform and is easy to develop. Not only is it easy to develop, but it's free and it's open source, whereby no plugins are required. Finally, in terms of our version control system, we've chosen GitHub because it shows the full history tree available offline, it has cheap months operations, and has an increase in operation speeds.